All right, so here's a quick little review of what we've been doing the last couple days, and then I'm going to segue into a word problem and how you can try to handle word problems. But so here's the two examples, and they're kind of random. This is actually from old notes. They were perfect, so I'm using them. This is probably notes I gave 3 years ago. But opening up, A is the thing that matters. If it's opening up, A is positive. If it's opening down, A is negative. So we've talked about that. So here I'm just reiterating what we talked about in class. And if you notice, when it's opening up here on the left, the vertex is the bottom point. Okay? The vertex is the minimum value of the function. If it is opening down, the vertex is the top point, is the maximum value of a function. Usually when you hear value in mathematics, it's talking about y value unless otherwise. All right, so the maximum value for opening down, and it's a minimum value for opening up. I'm referring to the vertex, of course. All right, so let's scroll down. Yeah, that's when A is positive. It's what's on the left. When A is negative, what's on the right. Now, domain and range for these, that's something we haven't talked about a lot, but domain is what x's you can have, and for quadratic functions, domain is always all real numbers. All right, that's what this means. So actually, let me make sure that's clear. All right, so domain is all real numbers. So in other words, it's all the numbers between negative infinity to infinity. So it's all reals, all real numbers. That's what that means. Okay, that's what that means. Same for that. Domain is all real numbers. Okay, no matter what, for a quadratic function. Now the range, how in the world did we get this? The domain is where the x's can be, the range is where the y's can be, and then the y's can be, well, for this one, y is -4 and up. That's where the y's are, forever and ever and ever and ever. Okay? For this one, it happens to be at 5 and down, forever and ever and ever and ever and ever. So what? What's that tell us about the range? Well, okay, domain's numbers. It's going forever to the left and forever to the right. This is going forever to the left and forever to the right. The blue one is. All right, even though it's not going left and right very quickly, it's going forever to the left and right. But in the y value side of things, the y values for the green one is -4 and up. So how we communicate that is, it's all the y values are greater than or equal to -4. This is -4 and above. This is the way we say that. Okay? And then for the bluey, for the blue one, it's from 5 and down, and the way we communicate that in mathematics is that y is less than or equal to 5. All right, so that's the domain and range. So domain for any quadratic is real numbers. If it's opening up, then you take the y coordinate of the vertex, it's everything above that, so y has got to be greater than -4. All right, here, y is always bigger than -4. Y can be -3, -2, -1, 0, 1, 2, 3, forever and ever and ever. As long as it's bigger than -4, that's what y can be. And then in the blue one, 5, 4, 3, 2, 1, 0, -1, -2, it's on. Forever down, that's what y can be for the blue one. So there you go. That's how you figure that out. If you need clarification, we can talk about tomorrow. All right, boom. So word problems. Stop. Pause this and read this. This is how we find maximum and minimum values using quadratic equations, using parabolas. All right. So pause this for a second and read these, and I'm going to scroll down because there's a step D here in a minute. All right. So, and then step D. Oh my goodness, I can't move it down apparently. Okay. Step D is use the x, y coordinates to enter a slightly different, sometimes you have to use the coordinates to answer a different question. So sometimes the x coordinate is what's being asked for. Sometimes the y coordinate is what's being asked for. Sometimes something else is going on. Okay, so oops, I got two examples I intend to do. Let's do them. Okay, so if 50 feet of fencing to section off your yard for a garden, what dimensions will maximize the area of the garden? So draw the picture. So we got the house. Okay, you got 50 feet of fencing. So 50 feet of fencing. You want to maximize the area of the garden. So let's figure this out here. If this is X and this is X, if X plus this has got to be 50, right? So at 2x has to be taken away from 50, okay, because we have 50 feet total. So this right here, 1, 2, 3, these sides have to make 50 feet. All right, so you take the 50 minus 2x tells you that it's got to be right here. Okay. If you add these up, you get 50. Okay, so it's 3/4 of a rectangle. You add up the three sides, x plus this should work out to be 50. All right, so you have to make an equation, and I'll use a of x. Okay. I maybe glossed over this a little bit. How do you figure this out? Well, remember, I mean, it's kind of, you've done things like this in like geometry, for instance. If you want to know three things add up to 180, you do 180 minus the stuff right? To figure out what's left over, right? So geometry might be fairly fresh in your heads. So the total angle is 180 in geometry, so you do 180 minus the stuff you already have. Here we have two x's. To figure out what's left, we do, well, the total here is 50. So we do the total minus the stuff we already have. So it's 50 minus x minus another x, or it's 50 minus 2x, okay? So what? Oops, I am hitting stuff I'm not trying to hit. So what? Well, what is the area then? The area is length times width. So 50 minus 2x times x, which is, now I'm going to distribute, and I'm going to put the x squared part first. So I'll go x times negative 2x is negative 2x squared. Okay, x times 50 is a plus 50. X, excuse me. And wait a second. This is a quadratic equation. Okay. This is a quadratic equation. So we want to know what dimensions will maximize the area of the garden. Well, finding x will tell us one of the dimensions, and then we can plug that in to figure out what this other dimension is. Okay, so if x was 10, we could figure out that this dimension would have to be 30. So it would have to be 10 by 30. So how do I get 30? 10 minus 2 times, 50 minus 2 times 10, and that gives you 30. 50 minus 20. That's not the answer. But, well, let's figure out what the answer is. So we have 50 feet total, blah, blah, blah. What dimensions will maximize the area of the garden? Well, if we scroll back up here, remember what you do. The hard part really is A, and we'll do a couple more examples of that tomorrow in class, probably. All right? So then you just got to find the vertex. Okay? So really, that is, the vertex is always at negative b over 2a. So negative 50 over 2 times negative 2. So it's negative 50 over 4, excuse me, negative 50 over negative 4, which is 12.5. Okay? So that is the x-coordinate of the vertex if you graph this parabola here. A of x is a parabolic function, or a quadratic function, which makes a parabola. By the way, it's opening down because A is 2, so check it out. It's opening down, so the vertex is a maximum. So when x is 12.5, that's the maximum area. That will give you the maximum area. Okay? Because you know that this is a parabola opening down. So the vertex is at negative 50 over 2 times negative 2, blah, 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 12.5. In fact, actually, 12.5 feet. Now, is this actually what they're asking for in the problem? They want to know what dimensions. Well, yeah, x is 12.5. So there you go. We're halfway there. Well, most of the work, though. If x is 12.5, then the other dimension, okay, hold on. Copy, paste. The other dimension is that. That's the width. So what's that got to equal? That's got to equal 50 minus 25, because 12.5 times 2 is 25, so it's 25 feet. So the dimensions are 12.5 by 50, or excuse me, 12.5 by 25. That will maximize the area of the garden. All right. So these are tricky. It's mostly the setting it up, and I feel like maybe I kind of didn't do the best job explaining it, but we'll try again tomorrow. Hopefully, second time's a charm. By the way, what if they had asked for the area? How could you figure that out? Well, that's figuring out the y-coordinate of the vertex. So sometimes they'll ask for that. If that had been the question, you just plug in the 12.5 into the area formula. Okay? So you got to keep track of what you're actually being asked, because there's a variety of things. They could be asking for the x-coordinate effectively, so they're asking for the dimensions, which was x. Okay? They could ask for the y-coordinate, which would be the area. Because remember, this f of x notation, that's y. Whoa, that's y. Okay, so they're asking, if I ask for the area, that's plug in 12.5, crunch the numbers, and you get some big number, and that's the area. They're asking for the y-coordinate of the vertex. All right, or they could be asking for something different, which is kind of the situation we had here, because we had to find not only this, which is the x-coordinate of the vertex, we actually had to find the other dimension as well. All right, so there you go. Hopefully that is helpful. Really only a couple of word problems we'll do tomorrow together. There you go.